The most remarkable telescope in history, the James Webb Space Telescope, is serving its motivation by giving us invigorating new experiences into the early phases of the universe and our own beginnings. As of late, specialists have found 6 Uber systems that shaped in the early universe when it was a hot, thick combination. The James Webb Space Telescope has proceeded to investigate and analyze these disclosures, and each perception uncovers significantly more far-off, furthermore old systems, each with unique qualities. However, the most striking discovery is the discovery of organic material, including the structure blocks of life, in one of these ancient and crude systems. This represents a breakthrough that changes how we might interpret the universe. Join us as we explore this incredible discovery made by the James Webb Space Telescope and what it could mean for our future. If you're interested in staying up to date with views from the universe and its environments, subscribe to our channel. Be sure to like this video and turn on the notification bell. Astronomers using the James Webb Telescope have succeeded in detecting the most distant organic particles known in the universe. This is the initial time complex particles have been viewed as in the distant universe. These complex atoms were found in a universe called SPT 0418-47, located a distance of more than 12 billion light-years. Given that the universe is approximately 13.7 billion years old, this universe is very old. The design, looking like a vast smoke ring, reveals the existence of complex organic atoms like smoke or haze. This revelation gives information about the substance interactions that happened in the earliest universes and their relationship to star development on Earth. These atoms, known as polycyclic aromatic hydrocarbons, are found in smoke residue, haze, motor exhaust, and forest fires. Organic atoms are based on carbon, considered one of the building blocks of life, as it is an essential element in the amino acids that make up proteins. Light from this dusty system began its journey across the universe when the universe was less than 1.5 billion years old, which is, in other words, 10% of its recent time of 13.8 billion years. Using the James Webb Telescope's limitless capabilities, which can detect light invisible to the naked eye and penetrate galactic dust, new insights about the world were captured. Furthermore, the Space Observatory benefits from a peculiarity known as gravitational lensing. This peculiarity occurs when 2 systems are perfectly aligned from our perspective on Earth, causing the light from the background galaxy to be distorted and amplified as it passes near the foreground galaxy, forming a ring known as an Einstein ring. Gravitational lensing was originally anticipated by Albert Einstein in his theory of relativity. Thanks to this increase in amplification, we can notice extensively the parts of a galaxy in the early universe that we can't otherwise see. During a careful examination of the data from the Webb telescope, cosmologists identified the mark of organic particles unexpectedly. This amazing discovery is helping cosmologists respond to some of the most key questions about the origin of the universe. It is astonishing that scientists can identify particles found billions of light-years away that are similar to those we know here on Earth, but are often associated with unwanted forms like cloud or smoke. Since its launch, the James Webb Telescope has been in the news for its observation of miles of vast galaxies. Now, the James Webb Telescope has made stunning new discoveries that could completely change our understanding and require a careful revision of all our cosmological theories. These notable discoveries could have a huge impact on our current knowledge. Continuing a series of discoveries questioning the Big Bang, the James Webb Space Telescope has seen as the most distant cluster of galaxies of all time, noticed a distance of 30 billion light-years. According to the scientists, this cluster is potentially one of the largest in the universe today. Although the 7 galaxies that make up the cluster had previously been seen with the Hubble Space Telescope, scientists didn't have precise information about their distance or whether they were truly bound together. Due to the time it takes light to travel from these distant objects to the location of the JWST telescope in orbit around the Sun, we are observing these galaxies as they were approximately 650 million years after the Big Bang. The present structure in which we see the protocluster gives the impression of being small. However, if we could observe it immediately without the limitation of the speed of light, it would most likely appear enormous, capable of exerting a gravitational pull on thousands of galaxies. Simulations by scientists suggest that this protocluster could be one of the largest groups in the universe today. Recently, the JWST telescope also made an astounding discovery when it observed a tiny galaxy that existed 13 billion light-years ago and has been forming stars at an extraordinarily high rate compared to its tiny size. This is believed to be the smallest galaxy of all time found at this distance. Roughly 500 million years later after the Big Bang, in a pivotal finding, a group of scientists from the University of Minnesota used the JWST telescope to peer more than 13 billion years into the past and found an exceptionally small universe that has been forming stars at an incredibly rapid rate given its aspects. This small system is beyond the capability of all telescopes except for the James Webb, and the first observation of this distant system is truly remarkable, said Patrick Kelly, lead author of the study. Although the world is around 1/1,000,000th the volume of the Milky Way, it is amazing that it continues to form the same number of stars every year. It's an interesting peculiarity. If you're wondering how the James Webb Telescope can observe such minute details in a field wide enough to capture the entire galaxy cluster at once, don't wait. The field of view of the impressive James Webb Telescope is sufficiently wide to capture the entire universe cluster at once. This is partly due to a peculiarity called gravitational lensing. Gravitational lensing uses lenses that bend and amplify the light from the mass present in the universe or world group. Gravitational lensing has played a pivotal role in making this small universe appear 100 times brighter than it actually is. In fact, this may be the first time we have had the opportunity to observe such a distant part of the universe almost to the exact moment of the Big Bang. The JWST telescope, with its excellent ability to track galaxies, has made this task easier than ever. So far, we have only had 2 space observatories capable of producing deep field images that allow us to see the universe in exceptional detail: Hubble and James Webb. Hubble works in the visible light spectrum, while Webb focuses on the infrared. Although both capture images of distant galaxies in the dimly lit area of the sky, the Webb images are sharper due to their infrared capabilities. When we compare the deep field captured by each of these telescopes, we can appreciate their remarkable differences. The Webb images have their own distinctive look compared to those from Hubble, most noticeable in the appearance of stars with their distinct pointed diffraction peaks. These peaks are unique features of the Webb images due to the shape of its mirror. Webb's ability to observe objects in the infrared gives it a significant advantage over other space telescopes, including its predecessor Hubble. Many objects that remained hidden or unnoticed in Hubble's deep field images are now being revealed literally by Webb. If things continue this way, 2023 is likely to be full of discoveries that will change how we might interpret the universe. However, who can predict with certainty what is to come? The James Webb Space Telescope, JWST, a wonder of modern astronomy, continues to unveil the secrets of the universe with each passing observation. Sent off with the intention of exploring the universe in exceptional detail, the JWST has already made significant discoveries that challenge and expand our understanding of the universe's beginnings and evolution. One of the key capabilities of the JWST is its ability to detect faint infrared signals from objects that are billions of light years away. This capability allows astronomers to peer back in time and observe galaxies as they were when the universe was young, just a mere fraction of its current age in years. By focusing on these ancient galaxies, scientists hope to unravel the complex processes that led to the formation of stars, galaxies, and ultimately life itself. In recent observations, the JWST has focused its gaze on a region of the sky known as the Hubble Ultra Deep Field, HUDF, where some of the faintest and most distant galaxies ever observed reside. These galaxies, found billions of light years away, offer a glimpse into the universe's infancy, revealing the conditions that existed shortly after the Big Bang. By analyzing the light from these distant objects, astronomers can study the chemical composition of the early universe and track the evolution of heavy elements like carbon, oxygen, and nitrogen. One of the most intriguing aspects of the JWST findings is its detection of organic molecules in distant galaxies. Organic molecules are the building blocks of life as we know it, and finding them in the far reaches of the universe suggests that the ingredients for life may be widespread throughout the universe. The JWST's ability to detect these molecules in such distant and ancient galaxies provides valuable insights.